Hello and welcome. Today, we're going on a journey through the male reproductive system. But we're not just looking at a static diagram from a textbook. No, we're going to follow its entire life story, from how it's first built before birth, through its peak performance, and into the natural, gradual changes that come with age. It's a fascinating look at some pretty incredible biological engineering, so let's dive right in.
So, let's kick things off with a question. When you think about the male reproductive system, what comes to mind? Beyond the most obvious parts, what are the hidden factories, the unsung heroes working tirelessly behind the scenes to make the whole thing work? Well, the answer lies with a group of small but absolutely essential glands. Here's the roadmap for our journey today. First, we'll meet the system's support crew, those accessory glands. Then we'll rewind the clock to see how the blueprint for the entire system gets laid out. After that, we'll look at the incredible fluid it produces, explore how the system ages over time, talk about some common health hurdles, and, most importantly, wrap up with how knowledge and proactive care are your best allies.
All right, first up, let's meet that support crew. These are the accessory glands. You can think of them as the mission control and logistics team, responsible for producing the fluids that nourish, protect, and transport sperm on its critical journey.
The main players on this team are these three right here: the seminal vesicles, the prostate gland, and the bulbourethral glands. Each one has a highly specialized job, and they all work together to prepare the cargo for its mission. To really understand how this team came to be, we actually have to go way back, to the very beginning.
That's right, we're jumping in a time machine and rewinding all the way back to see how this entire system is constructed from a tiny, embryonic blueprint. It's pretty amazing.
Okay, so here's something wild. In every single early embryo, both male and female, these structures called Wolffian ducts appear. They're like a basic foundational plumbing system. In male embryos, these ducts get the signal to stick around and develop into the core internal hardware, the epididymis, the vas deferens, and the seminal vesicles. So, who's sending that signal?
Well, the answer boils down to one critical hormone: testosterone. As this quote explains, it's the locally produced androgens, which is the class of hormones that includes testosterone, that are required to stabilize the Wolffian ducts. In male embryos, the developing testes start producing this hormone, and it basically tells the ducts, hey, you're needed, stick around. In female embryos, since that testosterone signal isn't there, the ducts just fade away. It's a classic case of use it or lose it, at an absolutely pivotal fork in the developmental road.
Okay, so the system is built. Now let's fast forward to adulthood. Those accessory glands are fully operational and hard at work, and their main job is to create the ultimate delivery vehicle for sperm, seminal fluid, which we all know as semen.
Now, this is where you can really see just how important those glands are. Looking at the composition of semen, something might jump out at you. The actual sperm cells, they make up a tiny fraction of the total volume. The vast majority of it is seminal fluid, and the undisputed heavyweight champion in producing this fluid is the seminal vesicles, contributing about 60% of the total liquid.
So what's each gland bringing to the party? They all have a very specific job. The seminal vesicles provide a thick fluid loaded with fructose. That's basically a high-energy drink for the sperm's long swim. The prostate gland adds a thin, milky, alkaline fluid that helps with motility. And those tiny bulbourethral glands, they secrete a slippery, alkaline mucus that does two things. It neutralizes any leftover acidity in the path ahead and provides lubrication. It's a perfectly engineered, multi-purpose cocktail.
And the sheer scale of this operation is just astounding. We're talking about a typical count of between 50 and 150 million sperm in a single milliliter of semen. It's a numbers game, really. Biology's way of playing the odds to make sure that at least one of those millions can complete the mission successfully.
But you know, like any complex piece of biological machinery, things change over a lifetime. And that brings us to the next stop on our journey: how the male reproductive system ages. Now, you've probably heard of menopause in women, which involves a pretty rapid hormonal shift. Well, the male equivalent, often called andropause, is a completely different ballgame. It's not a cliff. It's more like a very long, gentle slope. Starting around age 20, testosterone levels tend to decrease by just 1 to 2% a year. It's a slow, steady change that happens over decades. So what does this slow hormonal shift actually mean in practice? Well, it can lead to a number of physical changes. Internally, the machinery might slow down a bit, testicular tissue mass can decrease, and sperm production isn't as rapid as it used to be.
The tubes that carry sperm might get a little less elastic, and functionally, sexual responses may become a bit slower or less intense. These are all perfectly natural parts of the aging process.
And as you might guess, these age-related changes can also bring on some common health hurdles, especially when it comes to the prostate gland.
One of the most common conditions is something called benign prostatic hyperplasia, or BPH. It's a non-cancerous enlargement of the prostate, and it affects about half of all men as they get older. The easiest way to picture it is like this. The urethra runs right through the middle of the prostate. So when the prostate gets bigger, it's like putting a clamp on a garden hose. It squeezes the urethra and can cause all sorts of issues with urination.
Now, this next point is absolutely critical to understand. BPH is not cancer. I want to say that again. It is not cancer. The problem is, because it causes urinary symptoms like trouble starting, a weak stream, or having to go all the time, the warning signs can look a lot like the symptoms of prostate cancer, and that's exactly why you can't just ignore them.
So what should you be on the lookout for? Well, medical experts usually point to these 5 key signs. Blood in the urine is always a reason to see a doctor, no questions asked. Beyond that, you want to pay attention to changes in urination, any new difficulty starting or stopping, a weak stream, or a feeling of pressure down there. These signs don't automatically mean cancer, not at all, but they are your body's signal that it's time to go get things checked out by a professional.
And that brings us to our final and, frankly, most important section. It's all about using this knowledge to be proactive about your health. Because when it comes to this stuff, awareness is your best tool. So what does proactive care actually look like? Well, it really starts with just having a conversation. The general guideline is to talk to your doctor about prostate cancer screening around age 45, or maybe even 40 if you're in a high-risk group. This usually involves a simple PSA blood test and a digital rectal exam. The whole point is early detection, because finding something early gives you the most treatment options.
And of course, proactive care goes way beyond just screenings. Your overall health plays a huge role here. Simple, powerful habits. We're talking good hygiene, practicing safe sex, doing regular self-exams so you notice any changes, maintaining a healthy lifestyle, and steering clear of tobacco. All of these things contribute to supporting this system for the long haul.
When you step back and look at the whole picture, the journey of the male reproductive system is an incredible story of construction, peak function, and then gradual, lifelong change. It's a story that your body is telling every single day. So the final question is, are you listening to it?